So we're looking at discrete random distributions again today. This time we're looking at something called expected value. It's the value that you expect each time you perform some sort of experiment or a trial. It'll make a lot more sense if we run through an example. Okay, let's take one of the simplest examples I can think of. If you're rolling a dice, just a single dice, there's 6 different things that can happen. You can roll a 1, a 2, a 3, a 4, a 5, or a 6, and each of those has an equal probability of happening. 1/6, 1/6, 1/6, 1/6, 1/6, 1/6. Now, it's a strange thing to think about, but when you roll a dice, what do you expect to get? Or more accurately, if you roll a dice 100 times, what would be the average value of those things? I guess expected value, you can also think of it as average value. Now, when we talk about expected value, we use a capital E bracket. That's a big X there. Okay, so the expected value is equal to the sum of all of these values, the sum of X times the probability that the variable is equal to X. Again, that's a capital. Alright, so that still might be fairly confusing. All this says is that we want to add together each of these multiplied by the probability of it occurring. So that means that we're adding 1 times 1/6 to 2 times 1/6. So 1 times 1/6, 2 times 1/6, 3 times 1/6, 4 times 1/6, plus 5 times 1/6, plus 6 times 1/6. Okay, that's equal to 1/6 plus 2/6 plus 3/6 plus 4/6 plus 5/6 plus 6/6. Now that should be equal to 10, 15, 21. That's 21/6, which is equal to 3.5. So our expected value when we roll a dice is 3.5. Now that might seem slightly strange, so let me try to explain it in maybe a way that makes a little more sense. Let's imagine that every time you roll a dice, I pay you money. I pay you $1 if there's a 1, I pay you $2 if there's a 2, $3 if there's a 3, $4 if there's a 4, $5 if there's a 5, and $6 if there's a 6. Now, each time you roll that dice, you should expect to earn $3.50. Now, obviously, sometimes you'll earn $1 and sometimes you'll earn $6, but over the long term, you should earn, on average, $3.50 every single roll. That means that in 100 rolls, I'd be very surprised if you hadn't earned something very, very close to $350. That's what we mean when we talk about expected value. Just another really quick one. Okay, so here's a second example here. I'm trying to get away from the gambling idea, sort of. This time we're looking at a share, so some sort of stock on the share market. I've called my stock Instabook Chat. It's the latest technological craze, whatever. Now here is how the price of my share might change on any given day. So let's say Tuesday and the share market opens. Now the price of Instabook by the end of the day might have gone up by 15 cents. It might have gone up by 20 cents. It might have gone down by 5 cents. It might have gone down by 10 cents, or it might have gone down by 30 cents. Obviously, there's 2 good outcomes here and 3 bad outcomes for you. And we have the probability. So you can see the probability of going up 15 cents is quite high. The probability of going up 20 is even higher. And then these probabilities of negative values are here. Now, in order for you to decide whether you should buy Instabook at the start of the day and sell it at the end of the day, this is called technical trading or speculative trading. Let's see whether the expected value of this is positive or negative. If it's positive, we should probably buy it. If it's negative, we should avoid it. Okay, so the expected value of this share is equal to the sum of all of the things that can happen. Obviously, this is very simplified because absolutely any price would be possible here. Okay, so the sum of all of these, sum of this multiplied by this, so that's positive 15 times 0.25 plus 20 times 0.3. Now this next bit is plus negative 5 times 0.2. Really don't need the plus in there, but I'll just do it because that's what our formula is. Plus negative 10 times 0.15 plus negative 30 times 0.1. Let's see how that's look. Okay, you can see my next line of working here. 15 times 0.25 is 3.75, 20 times 0.3 is 6, and then we've got the negatives. Minus 5 times 0.2 is negative 1, negative 10 times that is negative 1.5, and finally negative 30 times 0.1 is negative 3. Once we add all that up and we get 4.25. Okay, so we have a positive expected value for this share, so it probably makes sense to buy it. Now, a word of caution, that means that anytime we buy this, we should expect to earn 4.25 cents. Now, word of caution here, that's our expected value, but on any given day, this, or this could happen. You could get 15 cents extra, 20 cents extra, 5 cents less, 10 cents less, and 30 cents less. You can see that there seems to be more, I guess, possibilities of failure with this share, but because the probabilities of success are higher, 0.25 and 0.3, this thing has an expected value. Now, if you do buy this share, don't come crying to me if you lose 30 cents. That's just the way that probability works. Over the long term, if you buy shares like this every day, you can average 4.25 cents every single day. But on any given day, disaster could strike. You could lose 30 cents, or something fantastic could happen and you could gain 20 cents. That's the nature of expected value. Okay, so now you can just jump into trying some of these questions out.